In this video we have three integrals to evaluate. If you look at the first one, the integrand is a rational expression. The degree of the numerator is 2 because you got an x squared there. Denominator has degree 1. So it's not a proper rational expression. For partial fractions, we need the degree of the numerator to be less than the degree of the denominator. So let's go ahead and use long division. Divide the denominator into the numerator, so it'll be x squared divided by x minus 1. X into x squared is x. Multiply times the divisor, this will be an x squared here. And then minus 1 times x is minus x. We subtract here. X squared minus x squared cancels, and this is 0 here. Minus the x, so this will be x here, plus x. And then we proceed, because the degrees are the same. We stop when the degree of the denominator is less. We stop when the degree of the remainder, I should say, is less than the degree of the divisor. So it's degree 1 there and 1, so it's x into x is 1. This will be a plus 1, and then 1 times x minus 1 is x minus 1. Subtract here, x minus x cancels. Again, this will be a 0 here, minus 1 is 1. So basically this rational expression would be the same thing then as x plus 1, that is the quotient here, plus the remainder 1 over the divisor. So we can integrate this instead of this. So I can rewrite this then as the integral x plus 1 plus 1 over x minus 1. And we can look at this as three integrals here. Integral of x, integral of 1, integral of 1 over x minus 1. But those are pretty basic. We can just proceed and say, okay, let's integrate with respect to x. X integrated with respect to x is add 1 to the exponent. That's 2, and then divide. So I can write it as x squared over 2, or 1/2 of x squared. The integral of 1, we expect to act. X is x. And then 1 over x minus 1, the integral of that, that's your typical natural log. We've done some of those. In other words, we could do a U-substitution here, and then u equal to x minus 1, and take it from there. But it's just going to turn out to be ln of absolute x minus 1. And then it's plus your constant of integration. As long as it's first degree here. If it's 1 here, coefficient here is 1, and this is just a constant here. It's always going to be that form. Is that plus 2? It's x plus 2. Now if there's a 2 in front of this x here, then it's divided by that coefficient. Say this is a 2 here. This will be times 1/2, or this is a 3. This will be times 1/3. So that's the answer for number 1. For number 2, this is also going to be a substitution. We've done several where we've had a radical, and we used formulas that led to the inverse of a trig function, either tangent, cotangent, sine, inverse, or inverse sine, inverse tangent, inverse secant. But this one here, though, notice if you look at the radicand here, the derivative here is 2x plus 2. So let's let u equal to x squared plus 2x minus 4. Then du would be the derivative of this. This will be 2x plus 2. Derivative of minus 4, of course, is 0. I can write this then as du, or dx, I should say. There's going to be a dx here. And then I'm going to factor out a 2 here, and then divide both sides by 2. So this will be a du over 2. And on the right side, since I factored out the 2, I just have x plus 1. So this will be x plus 1, and then let's multiply by dx. So then I can convert this integral here into one involving the variable u. So this will be the integral, and then x plus 1 here, look at this as a product here, x plus 1 dx, that's what I have here. And that's the same thing as du over 2. So this will be du over 2, or I can put the 1/2 out in front. And then I have the square root here, this expression here, but that's just u. Just to make it easier here, instead of writing a radical, I'm just going to write it to the 1/2. So that's the same thing as this right here, where u equals to x squared plus 2x minus 4. So then I take this expression, the u to the 1/2 to the numerator, that becomes u to the negative 1/2. And that's the simple integration. We add 1 to the negative 1/2, we get 1/2. And then divide the coefficient by 1/2. That's going to cancel here. So this is just going to give me e to the 1/2 plus the constant of integration. And then we always go back to the original variable, so I have the u. And since we started off with a radical here, I'm going to put this back as a radical, or square root in this case. Square root of x squared plus 2x minus 4. And it's plus the constant of integration. That's the final answer for this one. Square root of x squared plus 2x minus 4 plus the constant of integration. Now, the third one, we have the integral of secant of 3x tangent of 3x, integral dx. We know the derivative of secant is secant times tangent with the appropriate angle. So the answer here is just going to be secant of 3x. So notice, to check this, I take the derivative of this, and that should give me the secant of 3x and tangent of 3x. But then you have to use the change rule and multiply by the derivative of the 3x, which would be 3. So for this to work, I'd have to have a 3 here underneath, or multiplied by 1/3. That's the constant of integration. So the integral does equal to secant of 3x over 3 plus the constant of integration. Now if you wanted to do it so it'd be more clear to you, if you can follow this right here, that's fine. If not, you can write it this way. Let u equal to 3x. Then du would be the derivative of 3x is 3, and then it's here dx divided by 3. So then if you look at this, here I'll go here and put it over here. I'm doing the same thing, I'm just putting all the steps. Then I could just say, okay, this is secant 3x, and then using the U-substitution, this is u. It should be tangent of 3x, but 3x is u. And then the dx right here, dx dividing the 3 here is du over 3. I put the 1/3 out here. And then we look at it that way. Say, okay, we have secant u, tangent u. The answer to this is just secant of u. Because the derivative of secant of u with respect to u is secant u tangent u times the u. But in our case, what is u? U is 3x. So I put a 3x here. And then of course I have the 1/3 over here. I just rewrite it like I did the other answer, over 3 plus your constant of integration. Either way, you can follow this here. You don't really need this U substitution. Thanks for watching. We'll see you next time.